global energy transition is the monumental project of the 21st century. We are deploying trillions of dollars worth of smarter, cleaner, and more flexible energy resources. From utility-scale renewables and storage to microgrids and virtual power plants, fleet electrification and EV charging networks. These initiatives are technically and commercially complex. Our modeling software helps you see more opportunities, plan your projects virtually, avoid pitfalls, and maximize returns. Backed by a global team of energy experts, Gridcog is a comprehensive solution to make your new energy projects a viable reality. Let's take a look at what you can do with Gridcog. We'll start off by creating a new project, building up a simulation in our project designer, and then we'll jump over to the simulation output and take a look at the results. On the project homepage, we'll click Create a Project and first select the region we're modelling in. In this example, our client is in the UK and has 3 supermarket sites they want to assess for investment into distributed energy resources, or DER for short. This includes assets such as solar, wind, batteries, EV charging infrastructure, and flexible loads. The projects are behind the meter, so we'll pick that template. Each site is located in a different distribution network, which exposes them to a different set of price signals. We always start off with the baseline scenario, which represents business as usual. On each site, we can configure a number of parameters, including latitude and longitude, which drives the weather model for renewable assets like solar and wind, and other important considerations, like which market the site operates in and what tariffs they are exposed to. In this scenario, we've got a retail supply tariff and a network tariff. The next thing to set up in the baseline scenario is the value flows. This determines which participant is paying for what and allows the software to model the cash flows associated with DER investment, not just for the project owner, in this case the customer themselves, but also for the wider energy system. In this case, we want to know how this investment will impact the network owner and energy supplier too. Money in is on the left and money out on the right. Once we've created our baseline scenario, now we can get into the interesting job of creating some alternate scenarios. Here, we are virtually deploying some distributed energy resources to our sites to see how they will perform commercially. The easiest way to get started is to clone our baseline. We can rename it to something useful. Solar, storage, and EV charging. And now we can start to virtually add some DER. First, we'll add our EV fleet to reflect the need to electrify the supermarket's existing last-mile delivery trucks. We'll add the EV supply equipment to the site and then associate our fleet of vehicles with the chargers. Now, let's also include some solar in the mix. We'll assess a range of different solar options, which include variations on system size and orientation. Remember, the Gridcog software will model the performance of all of these variations, giving you the best chance of a good commercial outcome. Next, we'll add a number of different battery storage options, exploring a range of energy and power combinations, as well as different control modes. These will mimic how the asset will operate once deployed. Here, we'll just add CapEx, but for the storage aficionados, you can also tweak the technical parameters of the battery, including things like depth of discharge, degradation, daily cycling, plus a heap of other settings. That's the batteries added. In this example project, the aim is to figure out how each of our sites will be impacted by this DER investment. So we'll clone our newly created assets across our remaining sites. With the physical model done, the next job is to update the value flows for our new scenario to include additional commercial arrangements. In this case, we're assuming the customer is making the investment in the hardware, but the software also supports more complex value flows, such as third-party asset ownership with a power purchase agreement or PPA. We'll also run one scenario with a different commercial arrangement, whereby our site is exposed to wholesale markets and our battery can participate in ancillary markets. Here, we'll configure a bunch of important parameters, including which markets they are participating in, the probability of selecting the best market, and whether the assets are able to churn or trade between markets. The final job is to define which participant we're optimizing for. This instructs steerable DER assets to operate in a way that will maximize the commercial outcome for that party. And with that done, we're ready to kick off the simulation. While that's running, we'll quickly introduce another important part of our software, the library. This is where users can create and share reusable elements of their projects. Gridcog also provides common modelling components for all of our customers to use. A typical example might be network tariffs, which are often published by a network operator and stored and maintained within the platform for customers to use in their projects. Another example might be wholesale market price forecasts, where you are looking to assess your projects against a range of different energy market price assumptions. Gridcog has API connections to market data providers, providing a comprehensive set of historical data across the UK and Europe, but you can also upload your own forecasts. Within our Ancillary Services Markets module, you can configure a bunch of important market parameters that reflect market rules, such as block duration, energy throughput percentages, and activation pricing. We recognise that our clients' data may be highly sensitive, which is why our library includes a strict permissions model that allows content to be shared to individual client accounts, or even an individual project. Now, let's go back and have a look at the project that we left running. Due to the wonders of video, we haven't had to wait while the simulations are crunching. That can take a couple of minutes to a couple of hours, depending on the complexity of the project. But the chat feature notified me that we're ready to go. So let's jump in and take a look. To explain the simulation results, we'll be following the same basic process we did when we were designing the project. We'll look at the physical modelling first, and then the commercial performance after that. In the load profile analysis, we can see how the DER assets we've modelled will interact with the underlying load shapes for each site. The grey trace shows the load through the EV chargers. Yellow trace shows solar yield. The purple trace is battery state of charge. And the blue trace shows us residual grid draw. Notice how these all vary as either the physical characteristics of the DER asset changes or as the control strategy that they're operating under changes. Now that we have looked at the physical energy modelling side, and remember we've modelled several hundred different project permutations, the final job is to see how all this translates to commercial performance. The app has a number of ways of visualizing the commercials, but one feature that's most popular with our users is the project options comparison. This displays all the project variations that were simulated and ranks them by NPV, IRR, simple payback, or CO2 emissions reduction. As you can see in this example, across the sites we've assessed, there's a large number of different potential projects and a broad spread in terms of the expected financial performance. We won't go into too much more detail on the commercials here, except to say there are a number of different outputs offered within the app, like this relative cash flow forecast, showing future cash flows and how they compare to our baseline or business as usual. Our users can also use our reports function to download outputs of their modelling. Well, that's it. If you'd like to find out more about how Gridcog can help you model the complexities of multi-region, multi-site, multi-asset or multi-participant projects and get the clarity you need to accelerate your transition to a net zero future, please get in touch. Gridcog, the gold standard by which the smartest energy project investment decisions are made.